Hello to everyone. So I am Joe Houghes. I'm here to give a session that I normally actually give to VMware user groups. So typically this session is intended for folks that do zero automation for the most part. When I ask for hands, people have run PowerShell by just copying and pasting from VMware blogs. Most of them have never used Git to do a single commit, and most of them have never done anything with automating of templates or Terraform or Ansible. So hopefully this is mostly applicable to the audience, or you'll at least get something useful out of this, or even use this as proof of the things that your infrastructure team may be lacking, where you can go help them to advance their skills and improve your environments. Big thanks to all of our sponsors. I love the chocolatey folks. I met the majority of the team actually in PowerShell Summit in Bellevue a few months back, and then got to meet the rest of them here, so that's awesome. Big thanks to my actual coworker, Anthony Nocentino at Centino Systems for sponsoring, as well as ScriptRunner and Patch My PC, awesome products. So who am I and why am I here? I'm Joe Houghes, currently a senior solutions architect at Pure Storage. I'm in an interesting role, especially as it relates to the PowerShell folks, because I'm in a role where I actually do servers, networking, and storage all together as one combined product, and then primarily do infrastructure as code around all of that. Normally with Terraform and Ansible, less so on PowerShell than I used to be, but I'm still a user group leader for both the PowerShell and VMware user groups for Denver. I'm also a serial collector of communities, so I'm a Veeam Vanguard, a VMware Expert Pro, Cisco Champion, and Tanzu Vanguard for VMware's Kubernetes product. As we get into all of this, no matter what it is that we're doing, whether it's PowerShell, PowerCLI for VMware, or working with APIs, you need to remember the PowerShell basics. Hopefully these are things a lot of you learned. A lot of this is stuff that really comes derived from things like the Learn PowerShell in a Month of Lunches book, doing a lot of training with Jeff Hicks and Don Jones back in the day. Git-help is your friend, and it makes your life easier, right? Read the help, specifically read the examples to find out from other people that have already done this, what things you can do that you may not even be aware of. PowerShell is obviously built for the pipeline. You want to embrace and use this. This is going to continue on in a lot of your automation. We'll talk a little bit more about this, but think about the objects that you're working with and what other things you can do with those once you have them, once you've figured out a piece of information you need to find. Stacking your commandlets and results like Lego. I love giving this example. One of my favorite Lego sets is actually the Voltron set. I did that a few years back with my kids, and that took 9 days to do nonstop with my 2 kids. But it was a fantastic experience, and seeing the number of parts that went together and the amazing colors of some of the pieces that were internal to the final product that nobody else ever saw other than you with building it really stuck in my head. As you start doing a lot of this automation, many people are not going to see the steps that you go through or the multiple iterations when you realize you've skipped a page in the book and have to go back and take some pieces apart and rework it to get to a better finished product, or even to just a more correct next step that you're proceeding from. This is just for you to understand that the end result, the final product that you see, is not necessarily going to be the sum of the parts to other people, because they may never see the internals. But you want to make it easier on yourself for how you do these automation things. And then forget what your teachers told you. Cheat and look up the answer whenever possible. I love how many of us are absolutely hardcore in PowerShell that, number one, try and do the one-liners in as short a number of characters as possible, but it's ridiculous to most other people that are not niche geeks like we are. Also with this, do not fear using a GUI or using a graphical tool to go make changes inside of an environment. When you're trying to figure out how to do something, you can teach yourself by even just capturing these things within a variable, go and make a graphical change where you know how to do these things, and then go back and look at your results within another variable, right? So you can teach yourself the steps, or at least see other changes that you're unaware of that are happening under the covers by just doing a lot of this stuff. I now see Jeff in the second row, and I'm getting a little bit more nervous. As we move from PowerShell into Git, I just try and make sure number one, raise of hands, who's actually using Git? Wow, that's awesome. Okay. We'll kind of breeze through this one quickly, and I may even skip a portion of the demo on this. I just try and make sure that everybody understands how the Git flow works. And one of the biggest things that I see a lot of people have difficulty realizing or understanding when working with Git is that when you are working with things in your staging area, it is not immediately empty as soon as you start making commits, right? Essentially, your staging area should match what you have in production, unless you have other pending changes and things. but just trying to expose to people what happens and what files are on disk and what is visible to people when you're working in your Git repositories is one of the big things I try and hit on. And I even have a bit of a graphical demo to make it easier to show with leveraging some branching that we'll get into. And I like using this, and I've gotten some advice on this. Is actually a pretty good tool for helping people to understand a new process when they come into your organization, to kind of walk them through the steps and walk them through points in time of your code. So a thing to think about of how do you present your code to people that are entirely new to this. We'll breeze through 3 more quick slides. Packer is all about automating your golden images or AMIs or machine templates, virtual machine templates, whether you're using Azure, AWS, whether you're using even Docker containers, whether you're using Hyper-V or VMware environments, and just about making sure that the image that you start with, your base template, is up to date. When you now combine Packer along with Terraform, along with some Ansible after the fact, it's an amazingly powerful tool to make sure that your environment is always as up to date as possible as soon as you first go to deploy it, whether that's in dev or temp or staging or your production environments. You alleviate a lot of headaches by just automating even updates before you ever actually provision a template by using a tool like this. A lot of stuff on the slide here. Really, it's just to make sure people understand. Both Packer and Terraform are going to be using HashiCorp configuration language, HCL. It's a domain-specific language, but if you can read PowerShell, you can absolutely read this. If you can read YAML, you can understand HCL. It's really not that hard. One of the nice things about it is you can use a single workflow and provision to multiple environments. So even if you want to have a standardized machine template that goes to your VMware environment as well as your cloud environments, you can do all of this with one tool. When we move into Terraform, I always have fun explaining to people Terraform versus Ansible. The way that I've figured out that it's kind of best described in my mind is that Terraform will build your house and Ansible will decorate the inside of it. This is all about provisioning infrastructure, right? Typically with Terraform, this is going to be your virtual environments, especially if you are provisioning, say, an entire application stack for a particular developer or team that you want to make sure that all of your machines, all of your networks, all of your components that have to be part of this stack are all built together and kept in sync. You can use something like Terraform. Terraform is a fantastic tool in the fact that it gives you a consistent command line workflow for all of this. Again, it's HCL. This is where we make that step, as we saw that Sydney had presented in the State of the Show, where we've started with manual, we've then moved to imperative. That's us doing our scripting. We're now stepping into the declarative model. We want to define what our environment should look like, and the tool takes care of making that happen for us. So this is all about doing declarative configuration, multiple providers, and these providers are owned and managed typically by whatever product it is that you are connecting to with Terraform. So VMware owns the provider for vSphere. AWS or Amazon owns the provider for AWS. Microsoft owns the provider for Azure. So you're not waiting on a third-party company trying to keep up with the changes that happen on those platforms for you to be able to leverage the newest features. That comes from the developers of those teams themselves. The very, very awesome thing about Terraform is that it actually gives you state files. So you see what happens in your environment, and then it captures that state as a point in time and keeps those configurations and even a resource map for you if you want. It's very cool when you have a tool that will do a deployment and then even give you a graph of what happened after the fact. And then Ansible is just an automation framework. It relies either on SSH or Python. You're going to run all of this from a controller machine. Typically, this controller machine will have to be a Linux box. It's not possible to run Ansible controller on a Windows machine, so that's just how it is. In this, you are using inventory for managed devices, right? So typically you're going to have your environment set up and provisioned in whatever groups that you want, that you are aware of what these are. You're going to be working with things like a playbook, a module, and a task. You're going to have roles that are capable for doing multi-playbook or multiple file runs across these environments. And then a play is just provisioning an executioner from beginning to end, right? So just basic terminology for all of this. Quick raise of hands. Who's even heard of Packer before? Okay, that's one of those that I normally don't get the concept that spans much outside of the VMware environments primarily. Raise of hands of who's doing Terraform. Ooh, nice, more than I expected. Ansible, hopefully it's a bunch of, yeah. The one nice thing about Ansible, and one of the reasons I really enjoy it, honestly, even Terraform as well, both of these have the capabilities of running PowerShell under the covers for a lot of stuff that you're doing at provisioning time. So the fact that we have PowerShell as a glue language, the fact that we have a lot of advanced capabilities and a lot of history of things we do inside of PowerShell, you can still leverage this inside of these tools, but you can now use a unifying platform where you can provide value to your infrastructure team within these tools. And then Ansible will even extend to things that typically we can't necessarily touch with PowerShell unless somebody has put a lot of blood, sweat, and tears into a module to do things like managing network switches and additional hardware, right? So having these things where you can basically leverage a shared engine that can then run some PowerShell under the covers for it, very, very awesome utility to try and get your team unified on some of these things. So we're going to sit and run through some code demos, and hopefully my wife has been able to get my lab environment back up. We'll see. Shut the mic off. Come on. Yeah, I couldn't.
Are you going to use this one?
Yep.
Okay.
Okay.
Just
Okay. So jumping into quick basics of PowerCLI. I'm glad I ran this last night so I can at least have some code to show with this. Again, typically with most VMware administrators that I deal with, it is not showing on that. All right, awesome. Let's drag this back over. Nope. Hold on. Yeah, I know. It's not. I killed it, but nope, there we go. Huzzah. Okay, again, traditionally when I'm talking to vSphere administrators, most of them, they definitely did not come from a PowerShell background. So trying to explain to them things like being able to get the properties and methods on inventory objects that they have inside of their environment is somewhat of a mystery to them. Yet again, at this point, I feel like in PowerShell, there's a lot of folks that did not come in back in the days of learning the things like this is .NET reflection. A lot of people can understand it's Git member. So trying to bridge that gap from a lot of us that have been in PowerShell for a long time and have seen a lot of these things to try and bring people in new to it. It's always good to have in the back of your mind the perspective of what is their experience and what level can you talk to these individuals on to try and get everybody on the same page. So in this environment, first initially, I just connect to my vCenter environment. That's going to be my management plane that I have for this virtual environment. Then I'm going to get an object, which is a data center, which may have one or more clusters within the data center. This is supposed to map to a physical site, essentially. I'm going to have a cluster, which will contain one or more hosts, which is physical server hardware that's inside of this. So as I look at these, right, I can see that from my data center, I'm going to get back just a name object. From my cluster, I'm going to get back my name. I'm going to get my high availability and my distributed resource scheduling information. When I get down to the object of a VMware host, physical server host, we're now talking about the connectivity state, we're talking about the power state, and we're talking in terms of CPU and memory for this. These all just come from the predefined type formats that come in as the PS1 XML files. These are just the things that are defined that are the most logical sense that a vSphere administrator is going to be looking for these resources and they're going to be looking for this information the same as the view that you would expect to come back when you're running a Git service or Git process on Windows or a Linux machine, right? So it's just in terms of what it is that you're looking at. So same tooling, it's just that you have to put yourself in the mindset of you're in a slightly different context for what objects you're looking at and what sorts of information those people are trying to get. When I do things like getting my cluster and then getting a host, there's different information that gets returned on those objects, obviously, but getting people to understand the piping, I similarly take this back to explaining it to them in the terms that come with the GUI, right? They understand that there is a logical cluster, and underneath that cluster, there is a host that's a member of that cluster. So they can see that graphically. If you explain this, or whiteboard it out, somebody can understand this. So the easiest way to try and explain piping to them is to just try and tell them that essentially I'm trying to get a parent object and I'm now trying to get everything that lives underneath it, right? So explaining how to try and link these things together. If somebody does not know what commandlets exist that can be piped to each other based on these objects, then we can find this pretty easily, right? Hopefully everybody's aware of Git member, right? So I'm going to get my cluster object, and then I'm going to get the member. From the member object that comes back, we take the type name that we have here, right? This is going to be this VMware.vimautomation.vicore.implementation.v1.inventory.cluster implementation. Really, all that matters in this is that what comes back is a vSphere object from VMware.vimautomation, and then it's an inventory object, right? The inventory object just has a decorator for what type of system it came back from. But we can actually take the type name for this, and we can actually connect this in with git command and feed this in as our parameter type. So based on this being the parameter that I have for this, what commands that I have in my environment, in my loaded modules that know what to do with this. So I can now see that from a host object, I can attach, I can add another VM host, I can do a cluster, I can do baselines. There's about, I want to say 67 or 70 commands that come back from this, where VMware will do its best to try and work with this just based on the fact that it's an inventory object. Some of these commandlets do not necessarily make sense because it's not going to be able to take an action against this. But just understanding that you can quickly and easily find what sorts of things that you have as an option for you before you still have to apply the logic of, does it make sense for me to try and use this commandlet, is very powerful to try and help people understand how to start leveraging these tools in a more efficient way, I would say. Especially, again, if they did not come from the PowerShell space to start with, right? Trying to teach them how to use the tool in a more efficient manner based on the perspective that they have when they're coming to the command line on this stuff. As we start looking at doing more performant things within code, especially for anybody that's in the PowerCLI space within VMware, the objects that come back when you run the native commandlets, like a git-vm, is actually going to be a essentially .NET flavored object. It's going to take all the data that comes from the API. It's going to do additional processing. It's going to put some additional properties together to, again, give you properties that match the perspective of what a VMware administrator would see from this. When you're trying to get more performant data, you're going to really want to start connecting directly to the API to do a lot of this stuff. The first step you can do for this is just look at what information exists. So there's an extension data property that comes back on every VM object that we have inside of this, which will give you back this view. This view essentially is the same exact thing you're going to get back if you connect to the REST API for a vCenter environment and look at this object. It's a more categorical view. So it's more logically combined with what's inside of this, this PowerShell object. All of this information comes back under the covers. Being able to leverage these types of things means that you are not piping commandlets. You're not having to deal with additional formatting. You're not having to deal with additional overhead for a lot of this. You don't necessarily have to change all of your scripts and all of your tooling that you have at the point that you're already running them to determine where you can find this information, where you have additional methods that you can take actions against these inventory objects, and start slowly converting things over before you have to completely rewrite everything. So you can leverage the existing tools, the existing scripts that you have in place, and just have a more performant way of doing this. And it gets you a step closer to being able to leverage the API. I have an entire other session on Thursday morning, which walks through this in about a 5 or 6 step process of trying to help people move from PowerCLI and native PowerShell over to the REST APIs directly. And I use this because of the fact that a lot of the tooling and a lot of the documentation for VMware comes from trying to focus on helping infrastructure administrators get to doing automation. So it's written in that focus of, they typically don't know the tools, they don't know the language. So it's a very iterative process to get through this. But just understanding what information you have available is very powerful. So if I want to look at the information that comes in from my configuration of a particular VM, right, I can see that I have these properties here. I'm going to go dig into it. And I can now get information such as what was the creation date, right, where everybody can see that I was creating this system at 11 p.m. Mountain Time last night to get this up and running for the demo environment. So when you know that you have this information, it's very handy. If you don't know how to find this information for almost anything you're working with, I still go back to showing everybody the show-object commandlet that came from Lee Holmes in the PowerShell cookbook module, which I want to say has been around since 2015, maybe longer. Fantastic utility. Will give you a .NET pop-out for this. I'm going to actually see, my wife says my internet is up at home, so we're going to see if I can connect into my environment and we can actually run some of these things live. It's not looking like it. All right. We'll try it again in a few minutes. Okay, so basics of PowerCLI. Again, for Git, this one's a simple demo. The biggest things that I try and teach to folks that are new to using Git is what you should and should not put into Git. If you're entirely new to Git, start looking at things like just putting in your documentation, right? Work on text, work on things that are easy to change, that you want to easily be able to track those changes over time. I can't tell you the number of times that just having documentation tracked in source control, when you have an outage at say 3 a.m. and you can find out somebody made changes to the documentation that didn't necessarily match what got changed inside of a physical environment. That's great when it takes you, 7 to 15 minutes to resolve those sorts of issues rather than 3 hours when you're called in the middle of the night. Another thing that people do not necessarily think of is the things that you should hide from getting put into code repositories. If you're already using things like environment variables in your environments, great. That keeps a lot of this stuff out of your code repositories. But if you do have standardized file names or file extensions that you use, even if you're just loading in things like your hidden env variables for stuff like deploying Kubernetes environments, you can still have these that live within your code, but just make sure that they don't get checked into your environment with something as simple as a git ignore file. So looking inside of this environment that I'm using for this sample, all right, we have the same sample script that was essentially all the PowerCLI code that we were just looking at. And I have this super secret data MD file, which has a username, my password, my access keys. Oh my, we don't want to check this into source control. So to initially start this, right, as everybody knows, we're going to do a git init. We're going to check out the status. We're going to see that we have these 2 untracked files. Once we add in our sample script and run a git status on this, we're going to see that we have our sample script ready to be committed, right? But we have the untracked file for our super secret data.md. If we want to make sure that that does not get put in, then we're going to go ahead and get in and run this live. Sorry, I don't have this all set up for y'all because it was a little bit stressful trying to get here. Okay, so we have our 2 files. At this point, let me make sure, as long as my file path matches, we should be able to get in here and just do this. Yep, here, we can just run this within the, come on. Oh, why are you doing this to me? You know what, may just do it interactively in the command line. Can everybody see the dark mode? Should I switch to a light mode? Good enough? Okay. All right. Go in one more. All right. So we're going to go ahead and add our sample script.md1 file. All right. We're going to run a git status to see that we have this. So again, I still have this markdown file that's got information I don't want to have inside of here. So I'm going to do a code for a .gitignore. And by just copying in the name of this file, we can now save this gitignore, and if I go back and look at a git status of this now, we'll see that I have my sample script that's been added in, and now my untracked file went from my markdown to my .gitignore file, right? The one thing I will caution folks on, especially if you have a preset list of file names that you're putting inside of this, is when you check this gitignore into your version control, you will not be submitting in your environment variables and other things, but you will be submitting in essentially a list of files that potentially anybody that's scanning your environment should be looking for. I've had many, many arguments with security professionals that say we should never be checking this in. And I'm like, well, that keeps me from checking in my keys and all this into my code. So which would you rather I do? But they're still not typically happy with you giving anybody that's doing penetration scans or scans on your environment a list of what specific file names they should go looking for. So just a consideration. I don't have any better option than that. But again, just more to the point of what things you should and shouldn't be putting inside of your Git repositories.
Dumb question?
Sure. There's no dumb questions.
Okay, cool. Is that just file names, or do you have to do relative paths from the git ignore?
You can do relative paths. You can put in folder names. You can put in. Oh, sorry. The question was, when you're using a gitignore file, do you have to explicitly put in only file names? You can put in relative paths. You can put in folder names. You can put in explicit file names. You can use I want to say it's actually regex matching, but you can at least use an asterisk dot file extension and block every type of file extension inside of there. If you're actually working with developers that are developing code, typically they will do this to include their source directories, but not put in anything that they have for published binary files or DLLs or anything like that that actually gets compiled. That way it doesn't get checked into source code and doesn't bloat your environment by having tons of blob files that are put up inside of there. So you have multiple options for putting things in the git ignore for whatever it is you're trying to do. I typically try and recommend that folks come up with what is a standard that works across the majority of your environments and the majority of your code repos, to just make sure that if everyone starts with that git ignore file, then all of your known files that should be blocked are automatically secured by not getting checked into version control. Because once you put it in Git, you may just have to go burn down the entire repository and start over. That's just me being a Git Luddite as much as I am, right? There's probably a better ways to do it, but if you check your, access keys and any of your cloud resource access components into GitHub, I can guarantee somebody's already running resources inside of your AWS and Azure environments. Like people have bots that are out there constantly scanning for keys to be found, and they're going to already be provisioning things by the time you realize you checked it in. Flipping over to what we're looking at for, once we're past the git ignore here, and I'm sorry, this gets really hard to see when it apparently added a bunch of error code to this. When I go into this environment, we'll just go ahead and run this one locally. Oops. Because it's easier to see on the command line. Again, as I try and help people understand what it is that we're going to do with getting people trained up on what your process is, especially if it's automated. In this instance, I'm leveraging a code repository that I have that's actually for provisioning cloud resources inside of VMware Cloud on AWS, leveraging Terraform. And it was written in this way because I was doing this as a workshop, and we walked people step by step through what were the components and what were the changes that happened to keep step 1, step 2, and step 3 separate inside of this environment. So when I go through and do a git branch to list out all the branches that we have here, oops, as if I change into my environment first, we'll see that we've got a couple of different branches. Right now we're on main, which means we're at the most current point in time, and I've got 3 additional branches that exist inside of this environment. So if I do a git child item to just see what do I have here, if I can type. Oops. I don't feel bad about typos on screen. After having seen Jeff Snover fail at tab expansion, I feel much better about my demos being almost as good as Jeff's, right? So no, it's the reality of doing these things live. The easy way to see a lot of this is that we have essentially 1_, 2_, 3_ for these 3 steps that exist inside of this environment. The other thing that I like to do to actually show people what this looks like in a more graphical view to see this is as we start switching across these branches, if you watch the files that are here in the Explorer within VS Code, as I switch from branch to branch, you'll actually see these changes happen here. So if I go and do a git checkout on my branch for create SDDC. This is step 1, right? If I run git child item again here at the command line, I'll expand this out real quick. We'll see that we only have the files for step 1, right? Again, it's a little bit easier to just see this over here in VS Code as we do this. As I move over to step 2 and do a git checkout for my next branch of adding my rules, we will see that we now get step 2 that adds back into our repository. Whether you're using git branching for actually doing essentially software development and tracking of features and making sure that people are not stepping over each other, or you're just trying to convince an entire team to start leveraging Git to put these things in, if everyone is using their own branches, or even better, if everyone is using their own directories to just get them to consolidate things like all of their scripts and all of their documentation, you can prevent people having to deal with merge conflicts by typically just keeping everything in its own space and dealing with branches. But when you start trying to walk people through the specific steps, and especially because it's very distracting to start looking at everything and see exactly where we're at with some of this stuff, if you can write out some of your code, and as you have points in time that you actually want to walk people through your process that exists in code, you can make it easier for them to only see what changes there are from individual steps or what things are relevant to them at any particular point in time, right? A lot of this is just about making it easy for people to get in and to get started. The Packer stuff is going to be a little bit interesting with me not actually having a live demo environment, so I can't show everybody like what happens when we're in code, but we can at least just go ahead and open up all of our files and I can give everybody a quick walkthrough for what this is going to look like. So within Packer, right, very similar to what we're going to have within a Terraform environment. Both of these tools obviously come from HashiCorp and they both use the same HCL language. It's pretty easy to see a lot of this, and it's not completely dissimilar to the way that we think about a lot of things in PowerShell, right? We're going to define variables, right? This is going to pretty much match up with our param block in writing an advanced function. We need to tell Terraform, in this instance, Packer, what variables it's going to expect that we're going to try and feed to it when we make this run. So we're going to define all of our variables. You can actually put in defaults for these values that if you use the same 80% of the time, just set those as your default. You don't have to explicitly put these in here. But to Jeff's point that you always like having your defaults defined, you can always figure out what your default is. So if you're just running at the command line interactively, you don't have to have these defined in a separate file. You can also type what all of these variables are to make sure that you're doing validation on whatever input somebody gives you for these. So now that we have the variables defined for what it is that we're actually doing inside of our environment, this is where I'm defining user specific variables that come in. And this is going to be for my environment where I define essentially what's the server I'm going to connect to? What are my credentials? What are the environmental components of where I want to place a virtual machine that I'm going to put inside of my environment? And what resources am I going to give it to, along with things that actually get passed through to the operating system itself, as far as what do I want my username and password? What's the timeout for me connecting in via SSH to do a lot of these things that run interactively within the guest operating system itself? Right. In this instance, I'm actually even giving it a boot command where I tell it to go bootstrap off of a lot of files and then run even an update script after the fact. Right. So again, just defining more variables, but these are the ones that I'm going to give the actual definitions, and I may or may not be overriding what those defaults were where I just told it be expecting a value for this. Now, when we finally get to the actual run of Packer, I'm going to have a source, which is just going to be essentially the type of builder that I'm using for this. So in this instance, it's vSphere ISO, which tells Packer I'm connecting to a vSphere environment and I'm actually going to build off of an ISO file. And this is just the name that I'm giving it for this object where I'm going to reference this later on. Tell it essentially all the resources that I want, number of CPUs, how much memory, all the configuration for the disks, network adapters, and all sorts of these things. And then I give it the build instructions, right? Where I give it like my name, I give it the sources of what it is that it's going to pull from when it builds. At this provisioner level is where we can do things like shell. We can do PowerShell, we can do bash shell, we can do SSH commands, we can connect in via Ansible with this at this point. And then we have post processors for where we're going to take all this information and write it out to disk, right? So this is very powerful for especially being able to have a lot of these things in source control, where typically I tell folks keep their configuration inside of one repository and keep their artifacts or their assets of everything that come out of the end of the pipeline in a separate, hopefully private repository. That way you know what got provisioned at what point in time and you know what the results were from this. So it again becomes something where you can either import in these JSON files and determine what your environment was provisioned as and what it looks at over time and whether or not these are actually matching or not. Yes.
VS Code extensions did you install to do all of this? Like, how did that know that was a Terraform file?
That was honestly with just having the what extensions exist inside of here for getting the highlighters and the decorators for this. There's a Packer extension, and then when we look at Terraform, there's a Terraform extension that essentially just are doing language syntax. Right. So that's all it is giving us is syntax highlighting and some auto completion for it. I will warn everybody, if you are entirely new to Packer and to Terraform, start with the examples that exist in their documentation. It will give you a block you can copy and paste and drop into your code that will have an entry for absolutely every possible configuration item that you have. If you're never going to set them, just delete them. but it gives you every option that's there. You don't have to go figure anything out. You don't have to find it. You essentially can just read through all the options for what settings you can define and determine if you're going to use it or not, and delete those out, and then variable input for what those values are actually going to be. So quick run through for Terraform. I will say that for anybody that's getting started into this, especially to combine all three of these together, I like a repository that we have that is a big community project for a lot of us that have input in. Yep, sorry, it's dark mode. Anybody have any idea how to flip out of dark mode on GitHub when you're not actually signed in? I don't remember this. There is a Packer examples for vSphere code repository that is out here. Even if you don't use vSphere, if you don't even necessarily use Packer, or if you don't use Packer along with Terraform and Ansible, this is a great utility that was put together. This will actually give you a script that will essentially walk you through running a configuration for every Linux and Windows distribution you could want to do, including you being able to define whether or not you want to run standard and data center or only either for Windows builds. The greatest thing that I love about doing this is there is a provisioner that's in here that will handle your Windows updates. Who is used to having to build templates by following screenshots or text files of documentation to go through? I'm glad I'm out of the business of doing that. I update my templates probably once a month. Every one of my Linux builds and every one of my Windows builds are automatically patched and updated before. I don't know what happened there. Didn't touch it. Yeah. Thanks, Bjorn. Being able to kick off a script, or even better, have this in CI/CD where I just get a report that says it completed and I now have a template file that lives in my environment as an artifact, or seeing that it failed and I now only have to determine what changes happened or what things broke from last month to this month. But being able to see that these runs take anywhere from 3 minutes for my smallest Linux templates to about an hour and a half to 2 hours for Windows, doing all of the patching for every server and desktop flavor that's out there, but that requiring zero interaction on my part, is amazing, right? And I don't even still do, SCCM management anymore. I can only imagine if we actually had this, or when I worked in IT operations and we actually had to spin up our templates once a month to patch them and reboot 3 times just to make sure we caught everything is current, and then try and assume that somebody properly wrote this down somewhere to keep track of it. All that goes away, right? As we go look at Terraform, this, again, very, very similar to the Ansible. So we will just take a look at the files. This is a very simple deployment for an environment. And once we've seen the Packer, the Terraform is very similar, right? I'm giving it a definition of what variables it should expect that I'm going to pass in. Similar language and similar syntax layout to Packer. I can define defaults, I can define data types, or I can just leave this as blank where I'm going to give you the name of a variable that feeds into this. I then define my Terraform TFVARs, right, where I'm going to define my username, my password, what servers I'm connecting to, what are all the resources. At this bottom block right here, this is just where I'm giving it the name of a virtual machine, how much CPU and memory I'm putting into the environment. And then even the main play for Terraform is very similar to the layout for Packer. One of the nice things about Terraform is this definition of a backend, right? Again, because Terraform will keep a state file of what you've run inside of your environment, and it will check that first before it does changes to your environment, and will give you comparisons when you look at your live environment versus what your state file is. It will give you the differences. So if you're looking to see what's changed over time from your desired declarative state configuration to what actually exists live in your environment, you can see those different changes. So if somebody changes things manually outside of your infrastructure as code, it's easy to report on these things. But with this local provisioner, this means this lives on my hard drive, right? Terraform, like, not a sales pitch, but they have a Terraform Cloud free tier, which you can take these state files and it will automatically check it in essentially into version control on their side that you don't have to manage it. So if you lose your desktop or your laptop, you can automatically go pull these files back down and your state is protected by it being on their environment as well as your local environment. Similarly, we're, again, defining a provider. In this instance, it's vSphere, to just say I'm connecting to a vSphere environment. Now, for the Terraform, we have a couple of different objects here. These are data objects where All of this starts with my data center because this is the topmost logical object I have inside of a VMware environment that everything else is derived from. So in this instance, I'm having to connect in to go get an object of my data center. And because it's this data object, I can reuse this information later on. So since I've gotten my data center up here and I need to define this for my storage, my host clusters, my folders, all of my inventory information, I can feed back in just this ID because I've gathered the data one time, right? Similarly to how hopefully most of us in PowerShell will go get an object one time and then work against it because we have that data saved in memory in a variable. You can do similar things within Terraform for this. So all of these are data objects that we're having to collect to then define my resource object, which is what it is that I'm actually trying to put into an environment. So in this instance, this is the vSphere virtual machine. These first sets of strings that we have here in the parentheses are the actual definitions of what all of these object types are referring to within either Packer or Terraform. These are all defined in their documentation. It's very easy, again, to copy and paste all of this. If you want to build a vSphere virtual machine and go copy that block out of their documentation, it'll give you the 900-ish options that there are for this. Again, delete whatever it is you're not going to use. We just feed this back in here, right? I'm giving all my information about my network information, my network interfaces, my disks. In this instance, I'm actually cloning from a template. So I'm taking a template that was already built in my environment from Packer, and then I'm building an instance of a live virtual machine that I want from this. So I tell it where to copy from and what additional settings to set on it after the fact, right? Very simple run for this. Terraform is typically going to have, for most users, honestly, a 3-step because not everybody does full lifecycle deployment with this. You're going to do an initialize on Terraform, which will look at the, let me reopen that tab. It will look at this provider that we're using, and inside of its Terraform directory, we can even just do this live so everybody can see it. Let's do Terraform. So if I look inside of this environment, I only have my 3 Terraform files. When I first do a Terraform init, to initialize, it is going to say, I'm initializing the backend, which in this point is local, so it's just saving this file on my local machine. And it's trying to initialize the plugins. Because I have a definition of this vSphere provider, it's looking for a provider with that name. Since it does not exist, it actually goes and downloads from Terraform's registry the most current version of this plugin to then put it inside of your environment. And it's actually in here in the directory when it downloads everything, right? If I go into Terraform providers, under their registry, everything downloaded from each registry goes into a subfolder, and it will actually give me down to the specific version number, all of these blobs that actually come down. And this was a, 28 meg file. It's essentially an executable. The nice thing about this is you can lock these providers to a specific version. So again, you're only tracking changes across minor versions if you have things that worked last week and no longer work this week. Or if you're only ever going to use it once because you've determined that this works for everything you have for a need inside of your environment, you can actually keep all of these binary files. You can even check them into your own registries and keep your own versions of this, right? Similar to having a private PowerShell gallery for all of these things. But the 4-step or 3-step deployment for a lot of this stuff is doing a Terraform init, which will initialize, a Terraform plan, which will actually go connect to your environment, validate that it has proper credentials to connect to whatever the remote environment it is it's trying to deploy against, tell you what exists there compared to your definitions, and it will give you the plan of what it is that it actually needs to run. Let me see. I'm going to try one more time to see if I can get into my lab environment just to actually look at this stuff live. But when you run the plan, it's going to look at your desired state that you have defined here. Oh, man, this sucks. Sorry, y'all. I'm absolutely recording my demos for Thursday. We're not having this happen again. But the plan looks at your desired configuration that you have here defined inside of Terraform versus what's live inside of your environment, right? And it gives you the difference and tells you what steps are going to happen for it to meet your desired state configuration. When you like that plan, you can either output it to a file or you can just run Terraform apply right afterwards and it will make those changes. It will still confirm, do you want to do this, yes or no? Or if you're going to YOLO it, you can just do -- auto apply, right? Just why not? Do it live. The last step that exists for Terraform is actually a Terraform destroy. It will look at the state file of everything you provision inside of your environment, and it will go destroy those resources. Be careful with that if you are developing an entire stack of an environment for folks, because it will do things like delete your networks, right? If that's all defined inside of there. So be as contained as you want to be, but also be careful of what other things might be affected with this. And unfortunately, I'm actually out of time. So if anybody has any questions or wants to see the Ansible bits, we can afterwards. But thanks for coming out and I guess staring at the screen with me. So appreciate it.